Takže ja by som privítal Mira, je to skúsený DevOps architekt a prišiel sa s nami podeliť o svoje skúsenosti, ktoré nadobudol počas svojej IT kariéry. Takže Miro, stage je tvoj.
I will be doing this in English because it's kind of easier for me to speak English when I talk about technical things. So my theme is the technical debt and the cloud infrastructure, or you can do just one thing. So the agenda is, I will be talking about technical debt, about its causes, symptoms, and what people tried to fix it, and specifically how this works inside the area of the cloud infrastructure as a code. And I will also mention some path of mitigation, some of which worked for us, and some of which were kind of not so successful. First, a little bit about my bias. I'm talking about me not because I think I'm important, but because if somebody tells you something, it is always good to know something about that person. What is his or her experience? What is the bias? Therefore, whatever is being said can be interpreted in certain contexts. I've been doing this IT things for over 30 years. I started as I'm on the, my school is this school actually, or the school that was before this school. I started as a sysadmin, then worked as a developer for quite a few years, architect, SRE, and finally DevOps. In the last year, I started coding in C in late 80s, then Perl, C++, Java, C#, Python, and these days mostly Terraform, CloudFormation, and CDK. I work with the cloud from 2015, which is something like 8 years now. And the area I worked in is an enterprise level e-commerce. That is the e-commerce solution for a big systems based on a big frameworks, and Oracle Commerce and SAP Hybris. I lived on the both sides of the DevOps divide. I was developer and operations person, so I kind of know how the thing looks like when you are looking from this side or from that side. That means that we built and deployed e-commerce site, big e-commerce site. We released it, maintained it, supported it, monitored it, enhanced it, and essentially did it all over again. After 25 years living abroad, I'm back in Bratislava since the last 2 years, and I currently work as a cloud infrastructure team for a Canadian company that opened up conveniently an office in Spain, which is where I'm employed. What we do build cloud infrastructure, mostly in Terraform, and we also maintain over 100 AWS accounts for our customers, and they are running production workloads in this account. So our group is responsible for monitoring, troubleshooting, CI/CD of several of these applications. So this is about the bias. This is why I may sound a little bit not overly optimistic. So what is technical debt? Technical debt is defined as additional cost of changing or maintaining the software. So whenever you build something and later on you need to make a change in this software, you will find out that before you do something, you need to do something else. This is why the topic of my speech is you cannot do just one thing. Because the debt is almost always present in some form. So instead of adding features that you wanted to add, you work on fixing legacy bugs. You have to rework some decisions that turns out not to be optimal. It is quite often compared with a financial debt. It is like if you have a certain amount of money, you want to do something or build something. Instead of doing what you intended to do, you need to pay interest on a debt that you incurred in the past. Now, unlike the money, the technical debt is much harder to predict and quantify. It is not obvious at all when you start how much is there to do. So this is where, so in a financial situation, you usually know exactly how much you are going to pay for the interest, for your loan or for the debt. There are many causes of a technical debt. Some of them are good or considered good, and this is the conscious trade-off when you are building a product and you don't want to do, you essentially want to build a minimum viable product. you want to release it quick, find out how it works, and so on. So we made some decisions that you cut corners, you don't implement certain things, and it's in order to gain the speed. So this is the good cause of the technical debt. This happens mostly in product companies. It has a fine print, it has a consequences which say that essentially even the good intentions can lead to consequences that are not so good, but that's one of the good reasons of a technical debt. So this is something that you knew you are doing, you decided to do so, and you were fine with that. In a real life, there are often other causes of technical debt, and the first one is the time or budget pressure. You simply don't have enough time, the deadline is too close, or you don't have enough budget to do everything that the perfect product would require. So you do your best, and you leave some debt behind. And sometimes your requirements change late, and suddenly the decisions that you made based on the previous requirements are not the best decisions now. Quite often developers change, new developers come to the project, and the new developers don't have the same mental picture, same mental model as the old developers, and make some coding decisions that are contributing to the technical debt. If your project lacks of code quality tools or QA processes, it can also lead to a code that is not optimal and has some debt. Also, lack of knowledge on design and development side, or a lack of collaboration. So if you are having a distributed team and you don't communicate properly, you may end up with multiple implementations of the same thing, doing differently. So therefore, if you need to do that, redo that area of functionality, you are doing it twice or 3 times, depending on how many re-implementations you gathered. Quite bad can be when there is a lack of development leadership, there is not a strong team lead and strong architect, and developers simply pick their favorite tools and frameworks, and you end up with a project that has 15 different libraries in 4 different languages, and maintenance of such a product is much harder and much more costly, because you need a skill set that is much harder to get than if your project would be a little bit more streamlined. And then there is this hurry up and wait management style, that the decisions on the business stakeholders are taking forever, and the deadline doesn't move, and development team cannot move because it hasn't been approved yet, it hasn't been decided yet, and then suddenly you have much shorter time to implement things that you originally planned for. So that's the real life causes of the technical debt. The consequences are obviously missed deadlines, cost overrun. So because for each change that you want to do, then you need to do something else first, and that something else can lead to a different something else. Sad results of that is that often, in order to make the deadline, the teams postpone the actions and activities that are important for fighting the technical debt, such as documentation, tests, or code analysis. And it leads to a kind of a vicious cycle that the code base gets worse and worse. And if you don't apply some counter force, you will end up with a code base that has very high debt. When you try to quantify technical debt, it is important to realize that what is the standard you are comparing against, because there are 2 cases that I would like to introduce here. There is case one is you are building a sales demo or a proof of concept, and your intention is, I will build it, I will show the customer, we will validate the design, and we will then throw it away and re-implement it properly with everything that the project needs to have. And the second case is a production level project, it's a SaaS system that must have proper security monitoring, documentation processes, and so on. So if your POC quality is being measured against the production standard, you are wasting money, because you are implementing things that will never materialize. If your POC is really throwaway code, it doesn't really matter if it's debt-free or not, because it is not going to live forever. Nobody's going to work on it. However, if you do the opposite, if you build your product, your kind of production level code base using the standards that are good for POC, you will have something that is very hard to maintain. Therefore, it is important to understand what are you comparing about, what are you measuring about the depth. And sometimes it kind of automatically happens that your POC transforms into the production code. I've seen it happening in the past when the sales made presentation, customer was excited, was absolutely ecstatic, when can I have it? And the sales made promise, and you end up with something that was meant to be not to be used in production, to be used in production, and then development team started to retrofit, re-implement parts of that should have been there from the get-go. It cost more and takes longer doing it that way, trust me. There are many types of technical debt. The most classical one is the development depth, development quality depth, when developers are simply not doing everything that should be done, cutting corners, overlook. The worse than development quality are usually decision depth, when you make decision based on some short-term goals that turns out not to be valid in the long term. Therefore, the long-term consequences of the short-term decisions are not good. And it has implied effect on scalability, stability, and security. Then quite often we see the maintenance debt, that is the data accumulates and suddenly system breaks because nobody was really testing it with the amount. I once saw at a customer 15 years ago that had this brilliant idea of collecting unauthenticated sessions and persisting them into database. So the idea was that based on the cookies, when the customer comes back, they will have their shopping cart, which is a brilliant idea. But if you don't implement something that cleans up this abandoned session, you will end up with like 800 million records in an Oracle database, and it was in 2003 or 2004. And at the time, having that amount of record in a data center database was not an easy thing to fix. Deleting these records took days. So there are also vulnerabilities in libraries that you use third-party libraries. These libraries have vulnerabilities, and if you don't keep up with it, if you don't maintain and fix the libraries, replace the libraries, you will end up with something that will eventually, you will have to do it in the moment when you need to add a new feature. So instead of adding new feature, you are working on upgrading the libraries, and the upgrading libraries can lead to upgrading other libraries. So this is kind of the nice snowball. So we will end up working on upgrades instead of doing what you originally intended to do. Now we are getting slowly into the infrastructure and the cloud areas. There is this depth that I call a platform speed depth. And essentially, you're building on a platform, for example, AWS, and the platform is evolving. It's evolving very, very fast, and that evolution forces you to change things. So you have your product that works fine, or your code base is stable and you can do everything is okay, then you need to implement some add-on feature or change something, and then you suddenly find yourself, I need to upgrade this because Kubernetes EKS is already out of support. You need to upgrade that because you are using the old version of Helm or Terraform the speed of the platform, speed of the ecosystem is forcing you to essentially creates a depth for you without you doing anything wrong or without not following the best practices. Often when you are building a product, when you're adding new features, this causes issue that you did not anticipate. For example, you hit the design of the data model or some unexpected consequences of your decision. And if you are a system integrator that works with the vendors, there is this very special situation, which is I call it SI tax, system integrator tax. It's valid for the service companies that are implementing using the big framework. So it goes like that. You work with the platform vendors, I will not use any names, and you are selling a solution that is based on some platform. You are system integrator, you will customize it, you will implement the business features based on that framework. You go to the customer selects both platform and the system integrator. You are co-selling. You go there and the customer I need these features, and vendor says, oh, it's out of the box. Yes, it's absolutely, our system can do that. And you as a system integrator know that it is not quite so. It is that the feature is there but will not work for the customer and will require some customization. So, but you cannot really say anything because you want to make the sale. If you are tied to that vendor and you need to make the sale together, therefore you kind of accept that, okay, if we win this, we will have to re-implement or enhance this, and customer assumes it is not going to cost them anything extra because it is already out of the box. So this is this kind of special tax that you accepted when you decided for any particular framework for this thing. So I've seen that happening quite a few times. How do you eliminate technical debt? So it usually starts with assessment, and depending on the result, there are multiple paths ahead. So first path is kind of deprecated. If the cost to fix is so high that it's comparable to writing it from the scratch, then usually you are better off writing it from the scratch because you will starting from a more current, more recent starting point. And developers are especially happy to start rewriting stuff because what the old team wrote is never good enough, and we can always do better. We know that. But there was, if you know Joel Spolsky, he's the guy that gave us Stack Overflow among others. So that's he's a pretty big celebrity in the industry. He wrote back in 2000 or 2002, sometimes long time ago, a blog post warning against rewrite, and was using the example of a Netscape as a warning sign. And read that blog post, find Joel Spolsky and rewrite. It is easy to find. It is a very nice cautionary tale that tells you that not always the total rewrite is such a great idea and such a smooth thing to do, but often it is the right decision. So then you have 3 R's: refactoring, replatforming, and re-architecting. So refactoring is essentially taking your code base and changing pieces of it, replacing it with a better code without impacting the resulting functionality. So from the user perspective, system doesn't have any new features. It is still the same functionality, but internals are better. You usually work on better configurability, better logging, removing bad code, adding some documentation, some tests, some automation, and this is a great idea, and this is the right approach how to fight technical debt. The only problem with it is pretty hard to sell. So you are going as a development team spending I don't know how many weeks working, somebody pays for that time, and you are essentially not doing anything. And the esoteric argument that you are improving the quality of the code, well, the customer doesn't really care about that. They need a business functionality. The second one is the same thing as refactoring, only like from the platform point of view. You replatform. So often when your application hits the limits, then the solution is to use the brute force, lift and shift, and move it to the cloud. That often happens in the data center, where using the brute force and using big EC2s and big databases and SaaS databases and RDS and the other beautiful things that cloud gives us, it essentially gives the application ability to overcome those limitations that was experiencing. So. And the third option, this is the best one, but very hard to sell because it's the most costly one, is the re-architect. It gives you most options. It gives you ability to carve out pieces and replace them with the native cloud services. It essentially makes the application modern, makes the application cloud native. This is something that we always like to do, if possible, if we have opportunity. There is one catch. There is this shiny new toy. Sometimes when you do that and re-architect the application, you will end up something that is much more complex, requires much more resources, and much bigger team to maintain and monitor than the original things that was running in the data center. Again, I've seen that happen. So what is now different for the technical debt in infrastructure and cloud space? The first of all is a frequency of builds. So unlike the developers, we don't build infrastructure several times a week or daily. The infrastructure is built and stays built. Therefore, the new environments are usually released as part of the projects, not as part of the kind of the daily life of the project. So if the frequency of the builds is low, the chances of discovering technical debt on the next build is significantly higher. Also, the platform speed is very high, which also increases the probability of discovering that you need to do something else. You cannot do just one thing when you are building the next version of the infrastructure, because you need a new environment, or there are some new resources required in that environment. Also, tools evolve very fast. There are security patches coming at you all the time that you need to incorporate, and you have absolutely no control over these tools or platform. Amazon will do what Amazon wants, and the HashiCorp will do what HashiCorp wants, and you have to live with whatever they deliver. So the lifetime of builds is usually years without replacement, or a kind of many months. It is not like this application is being deployed and that version of the application lives, I don't know, weeks, maybe months. That's at the best. So what you build is there to stay. For example, this is the EKS Evolution. Just watch the versions in the left column, watch when it was released and when it's the end of support. You see that your platform jumps every kind of couple of months. So if you build something in 2 years ago, in 1.19, it is being long time out of support, and you need to upgrade it at least to 1.23, which will end up in October, in order to gain some time. If you want to plan ahead, you need to upgrade at least to 1.25, 1.26. And a very similar thing is for the Terraform, which is the Terraform evolves a lot, and it is a little bit more stable these days, but there were a day when they were making breaking changes. So if you had an old code base written in Terraform that was working perfectly fine, and you did not use the old version of Terraform tools to build it, you had to modify your source code. Also, what is different about infrastructure and cloud is that our testing is significantly harder and more expensive. So it is not like you run unit test, integration test as for the application. You actually need to build the application, and build the infrastructure. And building infrastructure and running it costs money. So your test is something that is not as easy to do or as cheap to do as the test for the application code. You have a cost of execution, the test, and also the cost to run. And the final test of any infrastructure is to deploy the application and see if it runs on that infrastructure, so which adds even more time. Then this is this state things, or state of the state. So when you build infrastructure, you store state of the infrastructure somewhere in the Terraform cloud, or in the S3 bucket, or if you are crazy, then on your local machine. Then this state is often changed when the new version of Terraform comes, and if you have an old enough build, you may end up and use the latest version of Terraform. You may end up finding out on the next build that the internal format of that state changed, and whatever you have stored is not valid anymore, and you need somehow to migrate it, or in the worst case, you will download a 30 meg JSON file, which is the Terraform state, and you will start your Vim or whatever editor you use, and you will start to change stuff in that file, and to make it work again with the latest versions of the tools. That's not something that you want to do. So avoiding that should be fairly high on your priority list. Also, speaking of state, we have this thing called drift, which is, again, doesn't happen for the application code, because nobody is going to go inside the binaries of your application and change something there. But it is very, very well possible that somebody logs on into AWS console, and your perfectly GitOps ready infrastructure as a code infrastructure is being modified by somebody that has permissions or doesn't know any better. And that person, if that person doesn't translate those changes back to the source code, you will end up with a drift. So the state that is actually running in the cloud, the state that the Terraform thing is running in the cloud are not the same. And you have additional tasks to do to reconcile the drift and fix that, either import the real state or make sure that whatever was changed manually in that environment is fixed. We have less advanced languages as the developers do. We have YAML or the HCL, which is not on par with a Python or TypeScript or Java or whatever languages you use. Yes, you can use CDK or Pulumi that allows you to write the infrastructure code in the higher language, like Python, for example, my favorite. And that they generate something like CloudFormation for you, but to debug, when something doesn't quite work in the translation, you will usually end up with a problem of debugging these things, which is not always so easy. So there is a trade-off. So, and also we have very complex ecosystem and very complex dependencies, and sometimes these dependencies are causing issues. Path to some mitigation. So first of all, what worked for us is manage expectation, plan maintenance and upgrades upfront. That means make sure that every stakeholder understands that when we build this infrastructure, there is an effort that needs to be invested in order to keep this up to date, and especially for if your customer is the first time cloud projects, they kind of assume, oh, you build the infrastructure as we did in data center, and it will be good for 4 years now, and everything will be fine. It's not so, especially not if you are using cloud native systems. You should use standard proactive measures like a quality tools, unit test, integration test. And what worked for us is kind of maintaining 2 branches of infrastructure code. One is the main one, which has the current deployed status and is version locked. That means that if you run it again, because it's version locked on the library version, on the tools version, it will build. So you can always build properly. And to have a other branch, call it latest, or that is the bleeding edge that is not version built, and you essentially, when you run it, it will get everything the latest out of what is released, and will try to build infrastructure using the latest state. And you will see whether that build succeeded or not, and you will see that when you try to do that as a part of some upgrade or deadline or something, that whether you will succeed or whether you will have to do something else before. Then it is a good idea to schedule regular fire drills. That means regular builds of both branches. Just do it. And if you can do it monthly or bi-monthly, but don't do it like once or twice a year, because as you see in those slides, this is not, the speed of the cloud is much faster than that. So you will know if everything is still okay. You will know if you can do the next hotfix, and you will know what lies ahead when you will try to build a new environment with the latest tools. It is also a great idea to monitor used open source libraries, because open source is both blessing and a curse. Because it's a blessing because there is something that is publicly available and it solves a lot of problems for you. But it's also a curse because you essentially don't control the direction. So if the project goes in the direction that doesn't suit you, you have 2 options. You either follow the direction or you try to create your private copy of the project, but then you lose the advantages of the things, because you will not, even if you make it properly as an open source, you will not find anywhere comparable amount of contributors as the main project. And it is not very popular decision to create your own version of something that is being used by many people. So don't create those forks haphazardly. So it is usually better to have 90% and open source than have 100% perfect for you and be responsible for maintaining it. And if you already do create your private copy, by all means, please make sure that your versioning and their versioning are compatible, because the worst things to reconcile is if you have a private version of some public module and your versioning is not following their versioning, then it is confusing like hell to put the things back together if you need to take upstream changes and integrate into your private repo. Also, consider reusability of the reusability advantages and disadvantages. People universally believe that reusability is always good. That means you always should extract shared code and have a library and so. But if you do that and you touch that library, you should, and you want to avoid any future surprises in the form of technical debt, then you should test that library with all the clients that use it. If you don't, you may have to do other things before you do that things that you wanted to do. So documentation is a key success factor. We work as remote teams, distributed teams, and good documentation can save you a lot of headache in the future. There is this link that I use. There is a nice blog post about the types of documentation and how you should structure documentation. We introduced it a couple of like a year ago and so, and it worked really well for us. You have to realize that test code is both asset and responsibility. That means it's good to have test code because it's really useful, but the more test code you have, the more test code you have to maintain, and test code can also incur technical debt. So your tests break because something in the test framework changed. And now you need to fix the test code in order to execute the tests first. Use automation, well, that's pretty obvious. Your build pipelines should be automated. You should be, you should code, everything that is being executed repeatedly should be scripted, but you are creating more code, which can contain technical debt. So keep that in mind when planning. And GitOps is usually a good thing, and everything becomes a code. The hard part about GitOps is to make sure that that is the only way. Because if there is a backdoor to the system in the cloud that it can be modified without the GitOps, then you will usually need to pay the price. So I'm pretty much out of time. I prepared a kind of a real-time, lifetime story with something that looked like I will do it in a couple of hours or so. There was this upgrading version of framework from Java 11 to Java 17. And there was a new phase of the project. We revived environment that was built in 19 and 20, and there was no budget for maintenance while the project was idle, so nobody touched it. EKS 119, and after our build was Dockerized using multi-stage build, so everything was fine on the build side. And once we deployed the Docker images, we found out that the Sonar fails. Well, the Sonar fails because the Sonar didn't recognize the class format of Java 17. So we said, okay, we will upgrade Java in Sonar. But then I found out that Java in Sonar cannot be upgraded so easily because it's tied to the version of the server, and instead of Sonar 8.4, I have to install 9.8. And the Sonar 9.8 used a different Helm chart because the Helm chart we used when we installed was deprecated. So, and the Helm chart that we wanted to use required Kubernetes at least 124. So within like 2 or 3 hours, I got from things I'm going to replace, change the Docker build, to something that I need to do EKS upgrade. So then I started to do the EKS upgrade. I found out that the Terraform code is old, and Terraform, it has some issues that I need to fix first, and the modules that we use when we build the environment hasn't been really evolving with everything else. So it essentially what looked like that'd be a very quick fix, and it took a couple of days to resolve. We ended up with 2 clusters, one just to compare the functionality. We had different set of issues, and then I, out of kind of desperation, tried to install ignore the recommendation of the class of the EKS version and install the Helm that required 123 into the old cluster, and guess what? It worked. So, so the lessons learned: don't let environment, even the development one, sit for 2 years without being properly maintained. Otherwise, we will accumulate some debt. And don't trust the documentation, try it out. And reuse is sometimes overrated because all those modules that we had to upgrade were in the end, they were more troubled than the actual benefit. Sorry. Okay. Do we have any questions?
The questions for you. What you can recommend with the versions of TF Terraform modules, strictly pin in infrastructure as a code, or deal with unpredictable applies?
Actually, I recommend both. I recommend these two branches that have kind of one is tied to version that certainly work, so that you can always run it, and then have the latest and run it regularly, so that you will see there is not a one right answer. You have, if you don't follow, if you don't upgrade, you will end up with something that accumulates technical debt. If you don't lock the version, you have unpredictability and you accumulate the technical debt. So you need to actually do both if you really want to be. That's the price for the speed of the platform.
So next, is React detecting in the way it consumes more resources and complexity acceptable if it brings more benefits to business?
Well, it is always a business decision, not a technical decision. In my experience, I've never seen one case when the engineers had a final say when it came to these things, but generally, re-architecting, if you can convince the stakeholders that the re-architecting will allow them to go into the territory they wouldn't get otherwise, that you may be successful. For example, if you re-architect something to cloud native and the elasticity of the Amazon will allow them to scale up within few minutes, it can be a critical component for the Black Friday. It is very hard to do the same thing inside a data center or without those cloud native things like autoscaler in Kubernetes and so.
So I think we have time for one more question. Is tool TF Autom acceptable in a case of eliminating tech debt with Terraform?
I don't know. I would have to figure it out.
Thank you, Miro. Thank you so much for your presentation.